Alright, so let's get into this. So, before you do anything, before we go through this at all, there's a mistake on the paper. This, where average income for each member is pi sub L. It's not subtraction, it's equal sign. So, just make sure you put another line underneath the one that's on top. And so, put these numbers to their corresponding equations. I'm just gonna go through everything. I'm gonna just forget about the numbers, but yeah, I'm gonna do these in steps, of course, and then explain the bottom. The bottom become clear after that. All right, so you have two screens here. I'm just gonna write on this left one, and this is the right one, just for a reference. So before we look at the equations, let's simply focus on the question at hand here. Alright, so Adam and his partners run a law firm which every member will earn maximum income. What does that mean? This maximum income part? Maximum income is just simply the maximum amount a person is able to earn. It's like a legal limit on how much an individual can earn in a business. So the purpose of this first part is really just to simplify the problem, because as we will see, if it made simpler because everybody just earns the same income is basically what this part is. The firm's profits are equally shared by each member of the firm. Pretty straightforward. I'll go more into that in a second. The firm has fixed current expenses with diminishing average product. Show how does the firm adjust the number of members if 1. the lawyer's fees increase, 2. the current expense increase. So first, before going back up there, let's just establish what are we trying to find. Over here, we're trying to find two things. The change in labor when lawyers' fees increase, and the change in labor when current expenses increase. Now, before finding out what this is, there's a couple assumptions here, right? This is obviously talking about production. This is a production function. So, output, Y, which is also income, is a function of both capital and labor. Labor is obviously the members of the firm, his partners, Adam and his partners. And so, the third part of this question, which says the firm has fixed current expenses with diminishing average product, these current expenses is referring to capital. And the diminishing average product is output divided by an input. The input here is going to be capital, so it's saying this right here. See, output versus capital, it's diminishing as capital increases. Output is increasing at a decreasing rate, I think is appropriate to say. And more wondering, like, what's the point of like mentioning that diminishing part? Well, it's not really that important, because it's assumed that all factors of production have diminishing returns. But yeah, it's just to establish that it's a regular production function. So now we go back into what we're trying to find up here. We're trying to find a change in L when lawyer's fees increase. What is the lawyer's fee here? The lawyer's fee is simply the price of service they charge a client, right? Sure, you've seen any type of law show. The fee is just the wage per hour that they charge when they work on a case. And 2, the change in L, labor, when current expenses increase. So we'll talk about 1K, current expenses. So there's another thing we should know from this first part. The change in labor when lawyers' fees increase is that the change in labor and the change in the price that they charge for their service are going to have a negative relationship. Why is that? Well, we have to also look at supply and demand. Here, supply and demand in the market, competitive. Price is determined by equilibrium price determined by the intersection of demand, which comes from the clients, and supply, which comes from the firm itself, at that quantity, right? So they're saying here that price is increasing, right? So let's say P1 is here. It's higher than P. And so we have a new quantity, which is, and probably think to ourselves, this change in price can only be achieved by a shift in one of these curves, right? Because, competitive market, that's how price changes. So the curve that shifts is going to be supply. So supply is going to shift up and thus be lower at every price level. The supply of goods. So at this new equilibrium, Q1 here, quantity supplied and quantity demanded. Quantity supplied, the amount of this service that the firm supplies, and quantity demanded, the amount clients demand that the firm serves, both fall, which also leads to a fall in Q. Now, how does this establish that L and P and the price of service are a negative relationship? Well, this comes from the fact that profit equals revenue minus cost. And revenue, as we know, R, this is revenue, total revenue, TR, R, same thing, and cost. Now, we can break this down even more. Revenue is P times Q, the price that they charge for Q amount of service, minus what are the costs to a firm, right? A cost to a firm are the amount it has to pay, the amount of dollars it has to pay towards labor and capital. And this, in our case, is represented, it's usually represented by this, which is labor times the wage rate minus capital times the rental rate. And you may have seen this in another form, like this is also another form of this. And this just comes from, now you're wondering why we're going with this actually, which is revenue minus the price of labor times labor, and the price of capital times capital. Now, why do we not go with this one right here? The reason is because, like, this is a production function, but since they don't say it's Cobb-Douglas, you don't go with it, right? This Cobb-Douglas are production functions, right? Cobb-Douglas being Y equals A. Oops, that's a terrible A. That's A. That's a production constant times K times L to the 1 minus A to the A, right? This is where MPL is labor income, marginal product of labor times labor. MPK is capital income, marginal product of capital times capital, right? If they said this was a Cobb-Douglas, you would go with this, but they don't, right? So So we go with the regular one we have. Let me just delete this, which is the y equals f of kl, and so normally it would be written like this, but Professor has it written like this. So just to know where this comes from, right? So I'm gonna be focused on this portion of the sheet at the moment. Okay, so as I was saying, what is profit, right? And I was describing, when I've been off a tangent, but I was saying how labor and the lawyer's fee, the price of the service they charge, which is this P right here, or have a negative relationship. And as I said before, just to go back, because I talked about a lot of stuff right there, I said price increase causes quantity demanded and quantity supplied to fall. And the reason they have a negative relationship, because with this fall in quantity, causes a fall in price, right? Now you're saying maybe like, oh yeah, price increase, but like, that depends on the magnitude. So we're just for our purposes, we're gonna assume this falls to a certain degree, right? And to offset this, because firms care about profits, they're gonna need to lower cost. C is gonna need to fall. So to offset this fall in revenue, so that this can be constant, right? Or at least great. They always want greater profits, but they don't want it to fall. And so, in terms of labor, how would you relate this, right? You have to figure out an equation that relates this, and that comes from average income here. Find the average income. Why is that? Well, the amount of revenue, or I should say, the cost of labor here, of like total labor, is LW, right? And it's a portion of revenue that goes towards labor. Now, as you probably figured out, that is income, right? Income. Whoa. What is income? Well, to realize this, let's go back here. Look at our flow chart. Good old macroeconomics, right? Flow chart established the flow of money and goods within an economy. This is households, right? Households provide labor, factors of production to firms, which then use that to create goods and services. These goods and services are then bought by households, which then goes to firms as revenue, and then this revenue gets sent back to households as income, which is rent, wages, profit, and interest, right? So income is a composition of all that. In this situation, income is going to be composed of profit and salary. Slash wage, right? Kind of the same thing in this situation. Okay, so then you're like, okay, fascinating. How do I make a formula? What do I do next to relate the L and P? Do I just use this? Some of you might be thinking, oh hey, this has P in it, this has L. Do I just solve for like L and put P on the other side? No. See, this is the firm's decision, and firm needs to figure out what their cost is, right? So the cost is the total amount of income that they're gonna pay to labor, to each member of the firm, including Adam himself. And so let me just erase this real quick, get this clutter out the way. And so the firm needs to just figure out how much it's actually paying all its labor, right? And that is actually its average income. The professor denotes this as pi sub L, which was super confusing. But yeah, this is average income. I'm gonna put that as income per labor. So to find the formula for this, we already know that we need to find out what income is. Now, as I said before, income is the share of well, I should say let me just take that back. Okay, so L times W, it's the total this is actually salary, right? As I said before, which can be seen from the flow chart, which seems to have disappeared. But anyway, I said, actually, let me just bring it up real quick. Flow chart. Here. Income is composed of profit and wages and interest, right? And in our situation, there's no rent here, there is no interest, so it's just profit and wages. Income is just total income, so it's total wages, right? The total amount of wages paid. So that's going to be the L times W, which is PL times L, P sub L times L, plus, I said profit as well, right? Is it total profit? Yes. So people might be thinking like profit is what's left of revenue after costs, right? And I think people are also aware that profit is used for things like investment and investment bonuses, stuff like that, right? So people would probably think it's only a portion of this, but from this problem, it says the firm's profits are equally shared by each member of the firm. So all that is all profits, pi, right? So basically, income is going to be composed of total amount of wage given, P sub L times L, plus the profit per person. This is backwards, but it's P sub L times L plus pi over L, right? That's how the professor got average income. This is denoted by pi sub L, income divided by labor in the bottom denominator, profit in top, because profit shared equally, and yeah, total wages towards labor, which it says P sub L here times L. Remember, as the TA said, I think professor said as well, that what's it called, variables, when you decide to denote them, this could be Z for whatever it is, it doesn't matter. Alright, so now we have average income per person. Now what do? We have an equation that's simply related profit, income and labor. But what does this do? How does it relate how L changes in respect to P? Well, we realize that he denotes here in max pi sub L the max income, which is pretty much everybody gets the maximum income here. PL max equals PQ minus P sub K times K over L. Where did this come from? This used to be that. No, it is. Well, it's not used to be. That is that. So this comes from profit equation, right? Where I just wrote this down in this section, actually. This is profit in C. Profit, this was brought to the left, so profit plus P sub L times L equals PQ, revenue, minus P sub K times K, returns to capital, right? Same thing. Now, why did he do that? Because we want this equation to also relate capital, current expenses, right? That is what capital is in this equation. Alright, so now we'll go to the next part of the equation. And let me just block off a certain part. We're on 2. Alright, so now we're on 2 here, right? We've established why these two have a negative relationship. We established the equations for profit, revenue minus cost, and what revenue is price. This is the lawyer's fee times quantity, right here, minus the cost, which is the wage rate times labor, which is the price of labor, P sub L times L, and capital times the rental rate, which is just price of capital times K. Income, composed of income, as I said before from the flow chart, is composed of profit and wages. So profit, as it says here, is shared equally. That's going to be partner income. Profit plus the returns to labor, right here, salary, wage. And yeah, that equals that. So now, what do we do with this? What do we do with this average income equation? Let me just make some space here. Delete some stuff. Oops. Oh, okay. Let me just delete this. Alright, cool. So, we have this right now. Q minus P sub K, K over L. This is a P, right? We have this. So now you're asking yourselves, 1, what the hell is this? And 2, why do we find derivative? Well, we need a rate of change, right? So what this is established in the question. This is how does this, it says right here, show how does the firm adjust the number of members if the lawyer's fees increase. That means change in labor, delta L, and change in the lawyer's fee, which would be change in P. So obviously we need to find some sort of derivative, right? So with this, we need to say, okay, what does the derivative of this show? The derivative of this, in respect to, it's going to be in respect to labor, is basically like how he has right now, D income, DL, which is a change in income in response to a change in labor. And this for a firm obviously represents change in cost, right? How total cost to labor changes with change in labor itself. So remember, this is quotient rule, right? This is division. So quotient rule. If anybody forgot what quotient rule was, it is what do you have here? You have g of x in denominator over f of x, and derivative, let me say d dx, right? Up, I can't. Yeah, this is d dx. Sorry for the sloppiness. D dx is in the denominator you have g of x. G of x, let me look at my notes. G of x squared over where's f of x? F of x is the numerator, p of k blah blah blah. F prime of x, no, g f prime of x, x prime of x, g of x minus f of x, g prime of x. Alright, this is quotient rule. You square the denominator, and then, derivative of this function times derivative of this times that, this times derivative of that, right? So, once again, getting rid of some of this stuff. Gonna reveal more of this. So we're going from 2 to 3 here, right? And it's super complicated. Well, I mean, sort of complicated, but let's just figure out like what he does, right? So basically, as I just said, f of x, right? F of x is going to be equal to pq minus p sub k, and g of x is going to equal to L. So for the denominator, I shall do denominator. It's just going to be L squared. Super simple. And for the left side is going to be g of f of x, this times g prime of x. F of x is just simply this, right? The quantity p q minus p sub k times k. G prime of x, this is in respect to L, right? The derivative of the average income is in respect to L, so this is just going to be 1. Simple, right? So, confusing part, what he does over here on this right side here. You would think it's simply, well, it is, right? It's dl of, let me try to write small, p q minus p sub k, right? So let's do the p sub k thing first, right? What is dl of p sub k times k? What is this? Oh yeah, if you didn't know, you had to find derivative of each one. Since the subtraction, you find derivative of this and subtract it from the derivative of this. So we're doing derivative of p sub k times k first. Sorry, I skipped a step there. So yeah, what is the change in returns to capital due to a change? This change in returns to capital. Returns. Okay. Right out the word returns to capital over change in labor. What is this? People are probably stumped, like, what could that be? This is 0. Now why? Well, what is returns capital, right? I said it's P sub k times k, right? Change in capital. Do you think that these two have a relationship? That if one increases, the other increases, or one decreases, the other increases? If you thought no, then you are correct. Now, why is that? Now, we don't have the actual production function here. So, no, I couldn't say, like, definitively they don't, but I can assume they don't. Because, one, well, if you've ever seen a production function, there's rarely, like, a situation where L is, well, you never have y equals k, where times L, where like k equals some constant of L, right? That never seen that before in my life. Could be a thing, but probably not. And that's because factors of production are, gathered separately. The quantity at which they're used is dependent on, like, their prices and the output that the firm wants to achieve, the Q. And so some of you might be thinking, like, wait a minute, like, what about this, right? We have this isocost line, isoquant, and we have at this intersection we have K, L, and this is L sub 1 and K sub 1. Now some of you might have thought of this when I said there is no relationship, right? But you're thinking like of this, and you're thinking of MR, marginal rate of technical substitution, which is equal to the negative change in K over change in L. And you're like, yo, Jeffrey, look at this. They do change, right? At least K. But it is not, well, first of all, level of output is not kept constant, right? So this Q1, yeah, this doesn't even apply because this isoquant, which is Q1, in this problem, it does not say output is kept constant, and we kind of really know it isn't, because I just established before from that Q is definitely changing. Because the price that the lawyers are charging for their service is increasing, so quantity demanded is going to go down, and so quantity supply is going to go down, and so yeah, Q is not even kept the same, so this does not even apply, and so yeah, this is going to be just 0. So that helps us out real quick. Let me get rid of this stuff and erase. Alright, well, I'm erasing this. So now all that I've established that this portion, derivative of this portion is 0, right? So I'll write, I'll say this equals, we're left with the L of PQ. That's 0, so I'm not going to write that in. That would be minus 0, but no point in even like putting that down. Minus PQ minus P sub K. K. Remember the 1 is there. Times 1, I'll just put it in this time. After that, I'll just get rid of it. L squared. Remember, the denominator squared. So now we have to find the derivative of this. Now you guys are probably thinking, which is what I did. PQ, oh, that's revenue. So then this would be D R of D L, which is equal to the change in revenue due to a change in labor, right? So maybe there's a way to do it like this, but it does not do in this method, which I did try certain things, does not get you to step 3, right? So then we have to consider like what to do. Well, first we have to realize something here, which is what the professor did, is that this ddl of PQ is equal to oh, wait, oops. What did I forget? Okay, I forgot this. L. My bad, guys, my bad. Okay, so okay, just make sure you just write that back in your notes. So, yeah, the g of x should be going here, which is L, and yeah, this is definitely f prime of x. Sorry about that. That can mess some people up. So yeah, then I gotta put L right here. My bad. So okay, so now I'll go back. So we need to realize that dl of PQ equals PQ dl, which equals P of dl q. And this is actually what the professor has. He has it in the form of include an L here, so I'm going to include all 3 or technically 4 of these. So he has it in the form of P times D Q in the numerator. Q is just up top here. DL times L. And that is where this confusing thing comes from, right? As to why this works, probably has to do with the, what is that, probably communicative rule property, which is with multiplication, you know, like 3 times 4, 3 times 4 equals 4 times 3. Probably has to do something like that, but that is how you get to the 3rd step. So, yeah, don't forget to put that L in, because, you know, f of x times f prime of x, which is the derivative of this, times g of x, L, that's important. Alright, so I'm going to erase this, and then, so, yeah, we're at here. Well, no, we're here right now. L squared in the denominator, PQ minus P is okay, and about to find the derivative of Q in respect to L. And so, as he has over here, d pi sub L dl equals P dq dl times L minus PQ minus PK over L squared. Now, dq dl, what is that, right? The dq dl change in q over change in L, right? Change in output from change in input, which is just MP L, right? That's all it is. So now we get second line. We get PL, oops, PL, MPL minus PQ revenue plus minus plus P sub K times K over L squared. Alright, this is a step he skips when he goes from 2 over here to 3. So now you're trying to see, you should try to see like common things here, right? I did this by going backwards, I think. So see what stays the same. This is here, this doesn't change, but then this disappears, as we can see, right? These two stay the same, so something happened here, right? So let me get more space for myself again, and I'll just do the numerator, address the numerator this time. We have PL MPL minus PQ. This is also plus, this is plus P sub K times K, but we're not worrying about that right now because that stays in the equation, so there's no need to manipulate that. Let's show you how he got there. So how do we get rid of this, right? Think maybe P sub Q was somehow added to this, but no. He wanted to get this value, or what it equaled, inside here. But the only way to do that is to have it be multiplied by something. So what I'm saying is, if you wanted to bring this, or some alternate version of this, into this bracket, it would have to be multiplied by PL, right? If this was PL MPL minus PL PQ, this could disappear and be simplified as PL MPL minus PQ. Right? This distribution, these two, same thing, this and this, same thing. So obviously, well, not obviously, it disappears, but this is the reason why it disappears. So just show you how he did that. We have to figure out PQ, or I should say PL, times some value x equals PQ, right? Divide PL by both sides, PL over PL, x equals Q over L, right? And so we can rewrite this PQ as PL, alright, rewrite the whole thing, and this changes PQ as PL times Q over L, right? When you multiply these out, this x is QL, so yeah, Q over L over here, this is that, it's equals the same thing. So yeah, PL times Q over L, multiply these together, the L's cancel out, this is P times Q, right? So this is how you get PL MPL minus Q sub L. And what is Q sub L? This is output per labor, and that is average product. So finally, this turns into MPL minus APL, and that is how he got that in the denominator. So the final version, well, for section 3 is going to be PL MPL minus APL plus PK times K over L squared equals 0. And we said this equals 0 because we want to solve for L, right? We have a rate of change, which is exactly what we wanted. And we want to see, we're still trying to find how L changes with P, the price of V. Now, we have L and P in this equation, and how change in L affects current prices. I mean, current expenses, right here, which is K. Okay, so now this is 3 on this side. So now show you how he got 4. So since the left side is 0, multiply both sides, L squared. L squared. That's just 0. This is just 0 on the right side, and so these cancel out. And then we get let me write down 4. I won't write that anymore, but we're on 4. We got PL MPL minus APL plus P sub K times K equals 0. Right. Yes, those cancel out. L. Alright, so then we're trying to solve for L because, you know, we need to find the change in L. And then, so, minus that. I shall do on the fresh sheet. So PL MPL minus APL plus P sub K times K equals 0. Remember, we did L squared both sides, so yeah, it's 0 now. And so subtract minus P sub K times K minus P sub K times K. Yeah, okay, I won't skip any steps here. So then we got P sub L MPL minus APL equals negative P sub K times K. Seems like my handwriting is getting worse. Well, with the computer anyway. But okay, negative, right? Subtract that, 0 here, negative P sub K times K. And so, still trying to solve for L. Divide by P. Divide P. Those cancel out, and you get, let me see if I can write this more clearly, P sub K times K over P equals L times MPL minus APL. Now I'm sure you can probably see what you're supposed to do next to solve for L. You divide this, but then you're like, wait a minute, that's not what he has written down. If I divide the MPL minus APL, the right side becomes, and the left side, which only has L, is negative P sub K times K over P A, oh, not A, goddamn, not A, MPL minus APL, right? But that's not what he has written down. This is different. So I'm not really sure why he did this. Probably, yeah, I'm not really sure why. I had to ask him. But the way you get 4, right? 4 is just simply switching this. I'll show you. MPL minus APL equals negative minus sign APL minus MPL, right? Negative, positive, you distribute the minus sign, this becomes minus APL plus MPL, which is just that. So that's what he did. There becomes, and once you do that, so I'm trying to skip any steps again. Negative MP sub K times K, and the negative comes over here. Negative P, and distribution, brackets, negative APL minus MPL, negative negative equals positive, so then you finally get P sub K over P APL minus MPL. Okay. So let me delete this and then I'll write the whole thing out. So we got, as we see here in 4, L equals P sub K over P A P L minus M P L, right? So now we have a equation relating labor here, and the price, the lawyer's fee, the price of service they charge, P. Now, as I said before, these definitely, you should intuitively realize, and I said earlier before, that these have a negative relationship, right? When one goes up, the other has to go down, because as I said, this affects profits go down when they increase the price, while quantity supplied and demanded go down once they increase the price, which lowers profits, and to lower profit, and when the profits go down, they need to counteract that with a lower in cost. When not profits go down, when revenue increasing the price decreases quantity demanded and supplied, which lowers the quantity sold, which lowers revenue. And to counteract this, and so that profits don't get diminished, you need to lower costs. And so they need to change, in regards to labor, you need to change the amount of people in the firm. And so we have to also realize how do firms do this. They compare average product of labor and marginal product of labor. So, as I think some of you will be able to recall, as I said earlier, average product in general is just output. Alright, here, average product, AP, is simply Q divided by an input. The input can be K, or K, or L, right? In this case, it is L. So, when deciding whether or not it's worth it to hire another person, a firm will look at this. They'll look at the output per person as average product of labor, and MPL, the change in output. I'll put here MPL, change in output, the results from change, additional units, a change in output that results from an additional unit of labor, right? They want to see how much they change output, an extra person will change output compared to what exists, how compared to existing labor. APL is average, so this is going to be a combination of the existing labor, the output they create, and the additional output that the new person creates, right? That's MPL. When MPL is above average, when marginal product is above average product, average product is increasing. So why is that? As I said, say, like, okay, we'll have L1, L2, right? Labor 1 and labor 2. Labor 2 signifies an additional unit of labor, right? A new person has been added to the workforce. See, L1 creates 4 units of stock, right? They create 4 units. And after L2, no, labor creates 5 units, right? Well, let's say more than that, right? Let's say labor now creates 7 units. And I'll take back what I said. This is relation between labor and amount of output they create, right? So initial labor without an additional person creates 4, then with that additional person, output is now 7. So that means the marginal product labor is 3, right? And so what does that have to do with, if MPL is 3, what does that mean for average product? APL, what does that mean for APL? This is, like I said, this is a quantity divided by labor. If before this new person, before they were making 4, but then when they added someone, they make 7. This new person added 3 more units, so then the average, which would be the quantity, the sum of the quantities of each laborer has increased. The sum has increased. That means that average product has increased as well, right? Because if this new person only created let's see here, they only added, okay, no, L3, right? If this let's say, L3, they added another person after this point. If output only increased to 8, this MPL, this new MPL, instead of being 3, MPL of 2 was 3, but MPL of 3 is only 1. It fell. Output increased by 1, but the rate at which it increased fell, right? There was a drop. And so this would make average product fall. If I'm not explaining this that well, I'm pretty sure there's a YouTube video about this. But basically what I am trying to say is that when marginal product, the additional output from additional unit of labor, is greater than average product, then average product is increasing. When marginal product is less than the average product is falling. So this intersection of the two is the amount of people the firm hires, and after it they don't hire anymore, and before it they don't, and before it they keep hiring. And so why is this important? Because this is to illustrate why the importance of this APL minus MPL. And so once again, going back to this question, change in L when lawyers' fees increase. I said that they got a negative relationship, right? So this is basically what this is saying, right? You could, I don't know if this is necessary, was it even necessary to find a derivative of this, because it's just kind of plain obvious that's going to be negative. But obviously if the price increases, this is going to have this is going to cause, if this price here rises, the denominator rises, which causes the value of this fraction to fall, and so which causes L to fall. So obviously derivative is going to be less than 0. So yeah, when P increases, L falls, the firm should reduce the numbers, obviously. And so what they're saying, and then for the second part, the change in L when current expenses increase, right? Expenses is this, returns to capital. So this is in the numerator. When this increases, L increases. And so when current expenses increase, they should increase slavery. And so, yeah. And also, this part, basically when APL, they're saying when APL is greater than MPL, so you're in this region afterwards. So yeah, that makes sense that you would actually hire less workers. They said diminishing average product, so that is when APL is greater than MPL. So yeah, after this point you wouldn't hire more workers, you would hire less. So yeah, that's why as P goes up, L goes down. So yeah, I hope that was clear. If you have any questions, I guess hit me up on the Facebook page, and yeah, that's it.